I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Magnetism and Electricity. This is a student reader in Unit 7. Electric charges, studying lightning. Joseph Dwyer studies lightning. He uses cameras and other tools to learn more about it. Joseph has even been in a plane that went through a thunderstorm. The pilot didn't mean to go through the thunderstorm. It was dangerous, but Joseph collected data from inside the storm. Joseph and other scientists still have a lot of questions about lightning. How does it get started? How does it move? Why does it strike one object and not another? This is Joseph Dwyer. What is lightning? Scientists know some facts about lightning. Lightning flashes happen because of atoms. Atoms are the tiny parts that make up all matter. The air is made up of atoms. Water is made up of atoms. Grass and trees are made up of atoms. Every atom has smaller parts. It has protons. Protons have a positive charge. They stay in the nucleus. The nucleus is the center of the atom. Every atom also has electrons. Electrons have a negative charge. Electrons orbit the nucleus. Here's a picture of lightning in a field. And this is a model of an atom. Opposites attract. The positive charge of the protons attracts the negative charge of the electrons. To attract means to pull together. Opposite charges attract each other. This is a pulling force. Like charges repel. To repel means to push apart. Two negative charges push away from each other. Two positive charges also push away from each other. This is a pushing force. Sometimes the negative charges in an object separate from the positive charges. This causes objects to have either a positive electric charge or a negative electric charge. The buildup of electric charge in an object is static charge. Charges repel. Opposite charges attract. Static electricity. Static charge can happen when two materials rub against each other. In some materials, electrons move from one material to the other. The material with more electrons now has a negative charge. The material with fewer electrons now has a positive charge. Look at the picture on the right. The child rubbed against the slide going down it. Electrons moved from the child to the slide. A static charge built up. The slide has more electrons. This gives it a negative charge. The child now has fewer electrons. She has a positive charge. Each of the child's hairs has the same positive charge. These positive charges repel each other. Each piece of hair pushes away from every other piece of hair. The hairs try to get as far away from each other as possible. This makes the child's hair stick straight up. Something similar happens when you take off a hat. Electrons move from your hair to the hat. Your hair is positively charged. This is why it sticks up. Static charge makes this girl's hair stand up. Surfaces that build up static charge are usually insulators. Electrical insulators don't allow electrons to pass through easily. This is how the electrons can build up in the object. Glass, rubber, plastic, and ceramic are good insulators. Electrical conductors are materials that electrons can easily pass through. Metals are common conductors. Silver, copper, bronze, and aluminum are all metals. They are good electrical conductors. These plugs have metal prongs. Metal is a conductor. They are covered in plastic. Plastic is an insulator. These wires are metal. Metal is a conductor. They are covered in plastic. Plastic is an insulator. Attracting objects. Objects with an electric charge can attract other objects without touching them. For example, a balloon is an insulator. If you rub it against your clothes, electrons move from your clothes to the balloon. The balloon has more electrons, so it has a negative charge. If you hold the balloon near a wall, an attractive force pulls the balloon and the wall together. If you have two negatively charged balloons, a repellent force pushes the balloon apart. The more charge an object has, the stronger force it will exert on the other objects. So here's a wool cloth and the balloon rubbed with wool. Here's a wall, the balloon attracted to the wall. And here's two balloons repelling. Static charge and lightning. Lightning happens when clouds get a static charge. Electrons move to the bottom of the cloud. They have a negative charge. The tops of the storm clouds now have fewer electrons. This gives them a positive charge. Objects on Earth's surface below a storm cloud become positively charged. The positive charge on Earth's surface attracts the electrons. The positive charge of other storm clouds can also attract the electrons. Electrons move from the storm cloud to the ground or to other storm clouds. We see this movement of electrons as a flash of lightning. Protect yourself from lightning. Go inside during a storm. Stay away from tall trees, the beach, or metal structures. They all attract lightning. Lightning flashes are moving electrons. What is an electroscope? Scientists can study electric charge with an electroscope. An electroscope is a scientific instrument. It is used to see if an object has an electric charge. Electroscopes are made up of a conducting material. This is so that electrons can move through it easily. If an object that has an electric charge is placed near the electroscope, electrons move freely through the conducting material. The electroscope includes one or more parts that can move. These parts often hang down. When electrons move through the electroscope, the parts will move because they become negatively charged. Negative charges move from the charged rod to the metal conductor. The charge spreads through the electroscope. The foil sheets become negatively charged. Like charges repel. The negatively charged foil sheets repel each other, causing them to spread apart. Magnetic forces, the world's strongest magnet. The world's strongest magnet is in Florida. It took 10 years to build this magnet. It is 6.7 meters or 22 feet tall. Scientists from around the world come to Florida for the magnet. They carry out experiments that use the magnet. Most scientists stay for a week. Andreas Neubauer is a scientist from Germany. He stayed for 6 months. Engineers have designed new types of materials with the help of the magnet. This is possible because matter acts differently inside a powerful magnetic field. This is part of the world's strongest magnet. Magnets have magnet fields. A magnet is any object that produces a magnetic field. A magnetic field is the area around a magnet that attracts or repels other magnets or magnetic materials such as iron. A magnetic field applies a force to other magnets or magnetic materials within it. This force can be a push or a pull. All magnets have a north pole and a south pole. The north pole of one magnet always attracts the south pole of another. This is a pulling force. However, two north poles will always repel each other. Two south poles will also repel each other. These are pushing forces. This horseshoe magnet attracted the iron bar. The force of this attraction pulled the bar to the magnet. Magnets are useful. They can attract or repel magnets or magnetic materials without touching them. But objects are only affected by a magnet within its magnetic field. A magnet's magnetic field is invisible. It moves from the magnet's north pole to its south pole. Stronger magnets have a larger magnetic field. A magnet's strength depends on its material. There are different kinds of magnets depending on their properties. Permanent magnets stay magnetized without electricity. Refrigerator magnets are permanent magnets. Temporary magnets act like a permanent magnet when they are within a strong magnetic field. They lose their magnetism when the magnetic field goes away. Paper clips and iron nails are temporary magnets. Many objects that have iron are magnetic. They can be permanent magnets or temporary magnets. It depends on how they are made. I learned a lot reading Magnetism and Electricity, and I had fun too. I hope that you learned a lot and that you had fun also. I'll see you tomorrow with another one. Bye!